Good day, my name is Carl Francis T. Encallado, and this video presentation is submitted as a partial requirement for CPE 13, Data Structures and Algorithms. For this project, I consolidated all our laboratory activities and examinations into a single menu-driven C++ program. In this presentation, I will walk you through each component in the exact order they appear in the main menu, explaining both the program's behavior and the structure that enables each function to operate correctly. Let us begin with the main program flow. The main function. The main function serves as the program's central control system. It prints a numbered menu, choices 1 to 16 plus 0 to exit, inside a do-while loop. The user types a number and a switch statement routes the execution to the corresponding function. The program keeps running until the user selects 0. The project uses two global integers, choices and repeat, so each activity can reuse the same repeat loop style to let the user run that activity multiple times before returning to menu. With that control structure explained, let's step through each menu entry in order. Activity 1. Basic Operations Program. Activity 1 introduces basic arithmetic operations. The function begins by requesting two integers from the user. It then carries out the four operations: addition, subtraction, multiplication, and division, while preventing division by 0 through a conditional check. The structure is straightforward: read input, compute results, display output, and offer repetition. With the basics covered, we can now move to the more structured visual output. Activity 2. Multiplication Display Program. Activity 2 displays a formatted 10 by 10 multiplication table. Its structure uses a string stream to construct the entire table before printing it to the console, ensuring alignment and consistent formatting. This pre-built approach helps maintain control over spacing and structure. Building on this idea of structured output, the next activity shifts into numerical decomposition. Activity 3. Denomination Breakdown Program. Activity 3 performs a denomination breakdown of a monetary amount. The function validates the input, converts the amount to centavos, and then uses a while loop to process each denomination from largest to smallest. At each step, it computes how many pieces fit and subtracts them from the remaining amount. This systematic reduction continues until the smallest denomination is reached. After working with currency breakdowns, we now progress to geometric computations combined with dynamic memory. Activity 4. Simple Circle Geometry Program. Activity 4 calculates the area and circumference of a circle and an ellipse using dynamic memory. The function allocates memory for each parameter, reads a single user input as the basis for all computations, calculates the necessary measurements, and finally, deallocates the memory. The structure follows a clear pattern: allocation, input, computation, output, and cleanup. From geometry, we now shift into working with two-dimensional arrays. Activity 5. Largest Number Finder in a 2D Array. Activity 5 identifies the largest number in a user-defined 2D array. The function begins by reading the array dimensions, then fills the structure using nested loops. Another pair of nested loops display the array, and a final nested traverse allocates the largest value. This structured approach, input, fill, display, and analyze, sets the stage for a controlled searching method, which brings us to our next activity. Activity 6. Number Search in a 2D Array. Activity 6 demonstrates a search algorithm on a predefined 4x4 array. After printing the array, the function accepts a target number and searches for it row by row. In each row, it checks the midpoint first, then searches either half depending on the comparison. This high-level search strategy keeps the process efficient. After exploring search operations, we now turn to sorting techniques. Activity 7. Sorting numbers in a 1D array. Activity 7 introduces three sorting algorithms: selection sort, bubble sort, and insertion sort. The structure begins by accepting 10 integers from the user, followed by a menu that determines which algorithm to apply. Each method is implemented using its corresponding loop structure. After sorting, the program displays the resulting array. With sorting in one dimension established, we extend the array manipulation further in the next activity. Activity 8. Insertion, deletion, and copying in a 2D array. Activity 8 works with a preset 3x5 array and allows insertion, deletion, and copying. The function calculates index location based on row and column positions, shifts element forward for insertion, shifts elements backward for deletion, and duplicates the table using nested loops for copying. After every modification, the updated array is printed. With foundational array manipulation complete, we proceed to a simulation of classic data structure. Activity 9. Queue and Stack Simulation. Activity 9 simulates both queue and stack behaviors using a one-dimensional array. The structure supports four operations: the queue, pop, and queue, and push. Each operation modifies the array by shifting values or locating appropriate empty positions marked with hyphens. After each operation, the array is printed with index labels, clearly showing the effect on the data structure. Activity 10 Vending Machine Simulation Program. Activity 10 is a vending machine simulation. It stores 5 items with quantities and integer prices, accepts valid Philippine denominations 1, 5, 10, 20, 50, 100, 200, 500, and 1,000, and accumulates money until the user types 0. After money insertion, the user selects an item number. The program validates the selection, checks stock, and ensures the inserted money covers the price. If all checks pass, it decrements the item quantity, computes change, prints a dispense confirmation, and a receipt showing total inserted, item, price, and change. This activity demonstrates transaction flow, validation, and a simple change calculation. Activity 11 Business Simulation Program, Pantropical Fruit Soda. Activity 11 simulates a single-session ordering system for an artisanal soda business called Pantropical. The function prints a large ASCII logo and business header, displays a 10-item menu with double precision prices, and runs an ordering loop where the user selects items, previews the selected item, enters quantity, and the program stores item names per item subtotal and quantity into parallel arrays. After the user finishes selecting items, the payment phase requests a payment amount and validates that payment greater than or equal to the total. Finally, it prints an official receipt that lists every bought item with quantity and subtotal, the total, the payment, and the change, and thanks the customer. Preliminary term laboratory test, hourglass pattern. K-Stall generates an hourglass pattern using @ symbols. The function first accepts a value representing half the height of the pattern. A decreasing loop prints the upper half using nested loops for spacing and symbols, followed by an increasing loop that prints the lower half. The mirrored structure maintains clean symmetry. From this mirrored pattern, we transition to a quadrant-based visual output. Preliminary examination, square pattern program. Case 13 prints a square pattern divided into 4 visual regions. Using nested loops, the function evaluates the position of each cell relative to the midpoint. Depending on this position, it prints an asterisk, an @ sign, or a blank space. This structured use of conditional checks inside nested loops creates a well-defined pattern. With patterns complete, we now focus on processing data in 2 dimensions. Midterm laboratory test, 2D descending sort. Case 14 sorts a 2x6 array in descending order. The structure begins by reading 2 sets of 6 numbers, then merging them into a 2D array. The function then flattens the 2D data into a 1D array, applies a descending selection sort, and reconstructs the 2D table using the sorted values. The structure clearly separates input, flattening, sorting, and reconstruction. With the sorting technique introduced, we now move to sorting mixed data types. Midterm examination, date sort program. Case 15 sorts the components of a date entered by the user. The structure begins by reading the day of the week, the month, the day number, and the year. The function assigns alphabetical ranking keys to the string inputs and sorts them using bubble sort while keeping them aligned with their original strings. The numerical day and year are stored in a separate array and sorted independently. This separation of string sorting and numeric sorting keeps the structure organized. Final term laboratory test. Case 16 implements the final term laboratory test, which focuses on array insertion based on a specific index shifting logic. The input base requests the contents of the first array, followed by automatic filling of the second array through repeated extraction and reinsertion. The output stage displays the updated contents of both arrays after each operation, making the transformation easy to follow. This activity demonstrates the EPO cycle clearly, accepting initial data, applying a step-by-step algorithmic transformation, and presenting the updated arrays at each stage. In conclusion, the entire compilation project follows a consistent input, process, output structure. Each activity begins by accepting data from the user, applies a defined algorithm to transform that data, and presents clean, readable output that reflects the results of the computation. Whether performing arithmetic, sorting, searching, pattern generation, simulation, or controlled array manipulation, the program maintains this same structural discipline. This EPO-focused design ensures that each module is predictable, maintainable, and easy to evaluate. Thank you for your time and reviewing my work.